we're starting with now. Today is the first day we're really doing your calculus. Is everybody with me? Chapter 1, lesson 2. So lesson 1 is just talking about some kind of like a review, but we already reviewed for a whole week. So start the lesson 2. Today's lesson's objective is estimate a limit using numerical or graphically. All right, that's what we're gonna do with using a Julia box. Next one is learn different ways to get a limit can fail to exist. And third one, study and use formula definition of a limit. The former definition is the one I will cover tomorrow because it requires a lot of algebra. So I want to do tomorrow a separate lesson than graphically and numerically. Introduction to limits. It sketches the graph of the function f of x equal to x to the third minus 1 over x minus 1 for value other than x equal to 1. You can use standard curve sketch techniques and you can also graph that. At x equals 1, however, it is not clear what to expect. Well, I want to let's practice first because remember we have done some, right? Let's just some number. I want you to evaluate some number like I had, 3 plus 4. Would you put your class name as Fall 2019 Calculus 1 class? Okay. And then put 3 plus 4 and shift, enter. Did you get 7? Okay. Let's try multiplication. 12 times 15. Shift, enter. Did you get 180?
Yep.
Okay. How about we evaluate some function? Let's evaluate a function called f of x equal to x squared. And shift, enter. Go ahead and do that. And do this. Type it in. Let's do some more function evaluation. So type it in f of x equal to x squared. So I will just do like you do. Then I'm going to shift, enter. Class has to be shift, enter. If you just enter means what? Go to the next line. But I want to evaluate. Then you have to do what? Shift, enter. So I am evaluating right now. I want to evaluate my function f of x equal to x squared. I want to evaluate my function f at 3. So it gives me a 3. Now look at this. I want to evaluate x equal to all this number, 1, 2, 3, 4, 5. I got 1, 2, 4, 5. I want this number to be evaluated. So I'm going to put x equal to this. Okay. Okay, so this is what I'm trying to do. I wrote it down to evaluate a list of numbers that we have to use called map. Map is built-in function. It's a mapping. One maps to one if it's f of x equal to say x squared. 2 maps to what? 4. 3 maps to what? 9. It's mapping, right? One to another, you're mapping. That's the same concept. That's why it's called map. Does it make sense to you? The built-in function is called map. So I want you to type this, map of map parentheses, and you need to tell them, I am going to map x to where? My function name is what? X squared. So I can do, I am mapping my x. Don't forget this is a parentheses. Do you want me to make it bigger? I'll make it a little bit bigger for the ones behind in the back. So map, type map. And whenever you see green writing, that means it's a built-in function you're using on their function. See, this is why it's so nice about Julia. You don't have to write this program. Somebody already wrote it for you. You're just using it. Okay? You're just using it. So type map. I am mapping my x to what? X squared. This is the error. What do you do? How do you make this sign? Negative, what do you do? Negative sign and then what? Error sign. Are you with me? So x, negative sign, error. And then my function name is x squared. Okay, in this case, I'm just doing x to the x, 2x, isn't it?
That's what I got.
All right, so I'm doing a 2x in this case, not x squared. That's fine. So do you want to do x squared, then what do you have to change here?
You put in shift 6, right?
Right. If I want x squared, I want to do x squared, then I need to do this. Right, class?
Right.
All right. Do you want to evaluate 1, 2, 3 is okay? X equal to 1, 2, 3?
Yes.
Which gives you 1, 4, 9, just like you wanted to. explain what you're doing here. I am, just like this graph, right? This is picture, that's the picture. You say I am mapping my x to what? X squared. How many x are you gonna map it? What's your x that you're mapping to? 1, 2, 3. So I put 1, 2, 3. If I want to do more, what do I need to do here then? I want 1 through 10, then what do I need to do here?
Comma.
1, 2, 3, comma 4, comma 5, comma 6, comma. Okay, you can do that. Class, if you're comfortable, then what's the name of this function that we're doing? We're doing this function, right? X to the third minus 1, x minus 1. So let's evaluate this one. All right, so I have 2 different ways I can do. One is, I don't like to put everything in the parentheses. I'd rather just put x and f of x.
Right.
Instead of giving f of x here, which I can do that. So this is what I decided to do. I'm gonna define my function first, which is my function is what? This right here. So x to the third minus 1 divided by what? X minus 1. So I'm gonna define my function first. Is everybody with me? To figure it out, because if you don't have a keyboard, how would you do shift enter? Have you thought about that? So it's like, this is a question I didn't think about it, but you know, that's something that we gotta think about. How would you do shift enter without the keyboard, you know? So this is a function that I want to find my limit. I want to know where the value comes to. Okay, what x do you want to do? This is the x. Remember this number 0.75, 0.9, 0.99, 0.999. Do not put the 1. You know that why? 1 does not have a y value. Remember that?
Right.
We have a limit, but we don't have a y value. So that's why I want to evaluate 0.75 at x, 0.9, 0.99, 0.999, 1.001, 1.01, and this. I just want all my x values because I don't want to use my calculator to do 1, 2, 3, 4, 5, 6, 7, 8 values. That's 8 times I got work. I'd rather put everything at one time. Just one. So you do your f of x and you define your x. Now, look at that. It gets a little bit easier on me because I can simply say what? I am mapping my x to what? F of x. What are you doing? Which x? The x I told you about. So this one is much easier to read. Did everybody see that? Everybody see that? This is the same thing as I did before, but this time I'm not typing in what the name of function. I just say, I am evaluating my x to what? F of x. I am mapping x to f of x. What x? The x that I told you in the above, right? The list of numbers I have, 0.75, 0.9, 0.99, those numbers. I don't want to put that in again, so I just put it right there. Because this is easier because if I decide to change my x, I go up and then what? Add numbers or subtract numbers, whatever I want to do. For example, I want my number to be even closer. So I can do what? Add 0.999, excuse me, 9999. Even closer to what? 1. So now I have a 5. I got one more number, but I'm not changing much. I'm adding one more number as what? It's this number, 3.003. Does everybody see that? Is everybody with me? Are you following? Are you just following me? Okay. I just add one more number, just because I want to show you why it's better to define your variables. I define x equal to what? All this. So if I decide to change my x element of my x, it's easier to just come over here and just add or subtract. I can add one more number, which is this. But I said, you know what? I don't need all this number. I'm just going to do 3 numbers. What I need to do? Delete some of the number. But do I need to change my function here? Do I need to change my program? I don't have to change any program because this just still works, right? But each one I'm going to say, okay, my x is go up and look at the numbers. So class, everybody with me about how to evaluate numerically. So this thing right here, I didn't do one by one. What do we do? do? We write a program to do it. Everything at what? Once. Is everybody with me? Has everybody done that? Because you can use this for your homework, right? So if I want to use built-in program, I need to bring the plot library. So that's how you call using plot. And I also use GR. I don't exactly know how it does, but I usually pair them. I use plot and GR. Okay, so doing this, using plot, GR parentheses. When you do using plot, you say plot, GR, backend. That's what you want to see. That means that's the one I'm going to use. So I am plotting, so I'm waiting. This is what I have. I'm going to make it a little bit smaller.
You lost me at using plots.
Which part?
The using plots, like I typed it in, just how you got it right there, and instead like argument error.
Okay, so did you put capital P? This, whenever you use their library, the capital letter and lower letter, they're completely different.
Okay.
Okay, so it has the capital P, plot, semicolon, and GR, parentheses. By the way, programming, let me just say one thing before you do anything anymore. Programming has to be precise. Okay, if you don't have your commas, if you don't have your semicolons, it does not gonna work because it says, I don't know what you're talking about. You understand? It's like it's a language. It's a language. You have to speak their language to understand that, right? Same thing. Yes. It's using plot, semicolon, and GR parentheses.
Well, you still have to be capitalized, right?
The P has to be capitalized, not GR. GR is just a, GR is not. So you need to do exactly like
So it's just that part that needs to be capitalized?
just the P. Just the P has to be capitalized.
So I did that, and I got it.
So when you look at this, remember the number that we gave? 0.75, 0.9, 0.99, and all that, right? So look at this. Graphically, at 3, what's your Y value be? 1. But did you see this line over there? Because I'm not so sure why, but it looks like to me at 1, it doesn't have any value, right? So it should be like, by the way, when you graph, it does not gonna give you circle. The reason is what? Because G approach to x equal to 0, where this is your G. All right, do that right now. So you need to figure out what G equal to. I'm not doing it, you need to do it. All right? Do just like you did the previous one. Define your G, and then what do you do? Define your X. So you need to choose your X, some numbers you want to choose. What number do you want to choose? Since I'm looking for something, I'm going to just define your X with you then. I want to probably do X to be what? I want something to be close to 0, right? So I will do some negative number. Okay. I'll do one number, 75. And then what? Negative 0.1. 5. What do you want to do? Okay? It's up to you how many you want to do, but this is the number I want to use.
How you do the square root?
Okay, square root is this, SQRT.
Squirt.
Squirt, that's right, SQRT, the square root. So you choose your number, guys, okay?
So our graph supposed to look different, huh? Our graph supposed to look different.
Little bit different, but not much.
Oh, okay.
So here's my GX. So I'm going to do X, this, and then what? Parentheses, squirt, X plus 1.
If you want to go down to
Alright, everybody that? I'm giving you what? G is supposed to be SQRT, X plus 1 minus 1. Everybody remember, this whole thing is your denominator. This is the whole thing is your denominator, so you gotta have a what? Parentheses.
Okay.
So who needs help? Let me come and see.